Okay, so last time we put together these cards, and each card had a different charge on them. And we came up with a formula by counting the cards. So for example, the first one here had 2 NA cards, so we were NA2, and then only one card, so O. The second card set here is very similar, so K, there were 2, and S. Now notice here, this is a 1, and for Na, but over here we just have 1 for O. So again, we don't write it in chemistry, but that's like having a 1. This was a 2, and notice right here we have a 2 for O. Look at the second set, it's the same thing. K was a 1 on here, but now S doesn't have a number here, so we know that this is a 1, and S was a 2, and K has a 2. Here's another combination, it's a 3 and a 1. Now I count my cards here, Al, Cl, 3. Notice how Al had a 3, but now Cl has a 3, and Cl was a 1, and we don't see a number here. Now Fe was a 3, and now we see a 3 in bromine, and Br was a 1, and now we get 3. So what would you predict for this one? Calcium was a 2, and notice we have 2 phosphorus cards. P was a 3, and now we have a 3. So what we're going to do here is known as the crisscross reduce method, and we're going to see the same pattern, and we're just going to do this without the card. So let's try some of these. Say I have Ca, and Ca is in the 2 plus column because it wants to lose those 2 electrons. And then let's use arsenic, and arsenic has 5, so it's in the 3 minus column. So we're going to call this a crisscross because it is like an X. So my 2 here needs to go here, and my 3 here needs to go here. So this is going to be Ca3, As2. We would get the same thing here if I use the cards, because this would be a 2 plus and this would be a 3 minus. So we'd have to keep going. Count your cards, same answer as we get this way. Okay, so if I have Li, which is plus, and N, which is 3 minus, it's Li3N. Again, crisscross, but we don't write the ones. Or let's say we have Ca2 plus, and we have F minus. So again, 2 and 1, so this would be CaF2. Okay, so crisscross reduce. So remember when we had Ca2 plus and O2 minus, it would look like this. It would match right away, so we wouldn't say Ca2O2. What we would do instead is just cancel these out. Now you could either do it up here, or you could go ahead and do the 2's and then realize that's not the simplest. So the simplest thing here would be CaO. So same thing, if I have Al3 plus and I have N3 minus, these would have matched. So it's just Aln. So again, instead of saying Al3 plus N3 minus, those can cancel out. Now we won't use this as much yet, but if I had a 4, you don't see too many 4s, but like Pb is one, and a 2 minus. Instead of saying 2 and 4, we would reduce that to 1 and 2, so this would be PbO2. Okay, so the next thing, polyatomics. So remember, polyatomics are groups of cards that are on the card. It's all one card, but it has more than one element making it up. A lot of these have oxygen in them. So these would all be examples of polyatomic cards. Now on these, don't move this part. These all stay together. You only move the charge. So for example, if I bring calcium to nitrate, the 2 comes over here, but since I need to keep this together, I'm going to have to put this in parentheses, and again, this is just a 1. Okay, and there is actually one positive polyatomic, NH4 plus, so if I combine that with, let's say, phosphate, PO4 3 minus, I would need to put NH4 here in parentheses and 3, so this is telling people that this would be made up of 3 positive cards, and this would all just be 1 3 minus card. So we'd write this NH4 3 PO4. Now the one card was OH minus. So even though this doesn't have a number in it, it's still a polyatomic, and there's a difference between writing this the second one is the way we want to do this, because this tells us we have a barium card, which is 2+, and then 2 minus cards that each say OH on them. So the first one would mean 1 O and 2 H's. That's not what we want to show people. We want to show 2 sets of BaOH2. If you're watching this, if you're absent or just want some more practice, I'm going to give you some to try on here. Once you've seen these, go ahead and just pause this video and then see how you did on it. So let's do Be2+ with N3- and Li+ with OH-, K+ with P3-, NH4+, oops, sorry, I wrote my 4 too small. They're too big. And iron 3, and let's combine that with, let's do P3-. Okay, so go ahead and write down your answers to these, and then you can pause it here, and then come back and see what I got here. Okay, so hopefully you tried these. So what you should have done is 2 here and 3 here. Change colors here. And this should have been Be3N2. These cancel out. I do not want to see parentheses on here on the OH. It would be wrong on the test. Here, your 3 and your 1 are going to switch, so this is K3P. Here, the 1 is going to go down here, but you don't need to write anything here. I'm just putting those temporarily so you know what's together. So NH4 and CO3 treat them differently, but they're groups. So NH4 then gets a 2, but I don't want to see CO3 in parentheses. It's fine to put it here for practice. And then these would cancel, leaving you FeP.